This is question 3 of the further maths exam from summer back in 2003, question paper 1. Let V1, V2, V3 be a sequence and let Un equal n times Vn minus n plus 1 times Vn plus 1. For n equals 1, 2, 3, and so on, find the sum from n equals 1 to capital N of Un. So this is the sum from n equals 1 to capital N of little n Vn minus n plus 1 times Vn plus 1. And we can see that this is, we can solve this using method of differences, where we can let f of n just equal n times Vn. Then that means that this sum here is actually just equal to f of 1 minus f of big N plus 1. And so that's just equal to 1 times V1, so V1, and then minus n big N plus 1 times V of big N plus 1. So that's the first part done. For the second part, it says in each of the following cases, determine whether the series U1, U2, U3 is convergent and justify your conclusion. Give the sum to infinity where this exists. Okay, so in this case, the Vn sequence term is n to the power of negative a half, or 1 divided by square root of n. And so if we go ahead and calculate the sum from n equals 1 to big N of Un, in this case, we get, well, let me just write it out. So n times Vn minus n plus 1 times Vn plus 1, and we know that that's equal to V1 minus n plus 1 times Vn plus 1. Okay, and in this case we know that V1 is 1 to the negative a half, which is 1, and then minus n plus 1, and then Vn plus 1 is just going to be 1 divided by the square root of big N plus 1, so n plus 1 divided by the square root of n plus 1. Okay, and so we know that that's equal to 1 minus the square root of big N plus 1. And so this is not convergent. Not convergent, since as big N tends to infinity, we have 1 minus the square root of big N plus 1 tends towards negative infinity. So the limit as n tends to infinity of the sum from n equals 1 to big N of Un does not exist. And then for part II, it's just n to the power of negative 3 over 2 this time. So the the sum from n equals 1 to big N of Un in this case is equal to 1 minus big N plus 1 divided by, and this time it's the Vn plus 1 thing is going to be n plus 1 times the square root of n plus 1, because it's n plus 1 times n plus 1 to the negative 3 over 2, which is exactly what that is. And so that's equal to 1 minus 1 divided by the square root of n plus 1. And this one converges to 1, since as big N tends to infinity, 1 minus 1 divided by the square root of n plus 1 tends towards 1. So the sum from n equals 1 to infinity of un is equal to the limit as n as big N rather tends to infinity of the sum from n equals 1 to big N of un, which is equal to the limit as big N tends to infinity of 1 minus 1 divided by the square root of n plus 1, which is equal to 1. So sum to infinity is 1.